Azure offers two key methods for defining and deploying infrastructure as code: Azure Resource Manager, ARM, templates, and Bicep files. ARM templates use JSON syntax, while Bicep provides a more concise, domain-specific language that compiles into ARM templates. Both tools simplify the provisioning process by expressing resources and dependencies in a declarative format. This approach enhances consistency, reduces manual configuration, and supports repeatable deployment patterns. When you use either of these formats, you describe the desired state, and Azure Resource Manager handles the deployment orchestration. This ensures that resources are created or updated according to the specified parameters, resulting in reliable and predictable Azure environments. When deploying compute resources, such as virtual machines, scale sets, or container instances, templates and Bicep files allow administrators to define configurations comprehensively. By consolidating resource definitions, networking settings, and storage specifications into a single file, these platforms help enforce uniformity across environments. For instance, deploying a load-balanced virtual machine scale set becomes straightforward when the instructions for network interfaces, load balancers, and VM configurations are contained within the same configuration file. This structured approach accelerates creation of scalable solutions while preserving control over naming conventions, region choices, and VM sizes. In turn, it aligns with broader DevOps practices for continuous integration and continuous deployment. ARM templates provide a declarative JSON-based syntax, defining Azure resources through sections like parameters, variables, resources, and outputs. The parameters section allows dynamic input, such as location or instance size, while variables enable storing repeated values for simplified references. Within the resources section, each Azure component, including virtual machines, virtual networks, and storage accounts, is declared with its type, name, and properties. Meanwhile, dependencies ensure that resources are deployed in the correct order. The output section produces serialized information from the deployed infrastructure, such as connection strings. With these building blocks, ARM templates simplify the process of describing and repeating complex resource setups. Bicep is an Azure native language designed to enhance readability compared to JSON-based templates. It supports a concise syntax that reduces duplication and streamlines resource declarations, using constructs like variables, parameters, and modules. Unlike ARM templates, Bicep handles nested or linked templates more naturally by allowing modular file structures. This approach facilitates team collaboration, where distinct resource sets can be grouped into separate modules. Bicep also provides features like enumerations for defining restricted sets of acceptable values, improving template clarity. These features collectively reduce verbosity and potential errors, making Bicep files more accessible, especially for administrators accustomed to scripting approaches. Parameterization separates environment-specific details from static resource definitions. Whether using ARM or Bicep, parameters accept user-defined values during deployment, such as virtual machine size or disk type. Employing parameters fosters reusability. The same template can target multiple environments by adjusting only the input values. For example, production might require larger VM sizes and additional subnets, while development uses more modest resources. In Bicep, parameters simplify the script by allowing default values and constraints. This approach reduces configuration drift and encourages the creation of standardized deployments, as you can customize the environment without altering the core provisioning logic. Templates and Bicep files allow authors to control the deployment sequence through dependency definitions. By specifying a depends on property, resources are guaranteed to deploy only after prerequisites are in place. For instance, a virtual network must exist before creating a subnet. In Bicep, dependencies are often inferred when a resource references another resource's name, with the compiler automatically enforcing correct deployment order. Proper dependency management prevents race conditions, ensuring that services relying on underlying components, like virtual machines needing an IP address, are provisioned correctly. This consistency reduces failures and facilitates error handling when deploying multiple, interdependent resources. ARM template and Bicep deployments can target various scopes, including a specific resource group, subscription, management group, or even a tenant. By selecting the scope, you can define where and how your resource definitions will be created. Deploying to a resource group is the most common approach for grouping related services, such as VMs, storage, and networking. However, subscription-level deployments help set up cross-resource group policies or network elements spanning multiple applications. This flexibility supports complex organizational structures and streamlines large-scale topologies. By adjusting scope, administrators can coordinate consistent deployments, manage shared resources, and apply policies or role assignments efficiently. When deploying files to Azure, administrators can choose between incremental and complete modes. In incremental mode, Azure Resource Manager adds, updates, or deletes only those resources defined in the template. Existing resources not included remain unchanged. This mode is safer for environments requiring minimal disruption, as it focuses on changes. Conversely, complete mode removes any resource in the target scope that is not defined in the template. If a resource group must strictly match your declared state, complete mode delivers consistency by eliminating unauthorized objects. Deciding between modes depends on organizational policy for environment control and the scope of intended changes. Before applying changes, administrators often validate templates or Bicep files to catch syntactical or dependency errors. Both Azure CLI and PowerShell offer commands like AZ deployment group validate or new AZ resource group deployment with the what-if parameter. This step identifies potential issues, such as conflicting resource settings or invalid property names. Automated testing pipelines may also verify template syntax, ensure conformance to organizational standards, and confirm that parameter defaults align with best practices. Code reviews are equally important, as they prevent misguided deployments. Comprehensive validation pipelines help maintain reliability, protect production environments, and provide confidence in large-scale or mission-critical deployments. Administrators commonly deploy either ARM templates or Bicep files through Azure CLI or PowerShell. In Azure CLI, the AZ deployment group create command references a template file, ARM or Bicep, and a parameter file, if desired. Conversely, PowerShell offers the new AZ deployment command, guiding administrators through the deployment scope, template path, and parameters. Below is a simple CLI example. Bash AZ deployment group create / name my deployment / resource group my resource group / template file main.bicep. These tools share similar functionality, enabling version control integration and consistent resource management across development, testing, and production.